Hello dear students, in this video we'll continue with the revision on numbers quantification and numerical applications. The next topic we have is alligation or mixture. First we will see some questions from last year's term 1 board question paper and sample question paper, and then we will see the other types of questions on alligation or mixture. Now this question was given in last year's term 1 board question paper. 20 liters of a mixture contains milk and water in the ratio 3:1. The amount of milk in liters to be added to the mixture so as to have milk and water in the ratio 4:1 is. So here we can see that we have 20 liters of a mixture which contains milk and water in the ratio 3:1. We have to find the amount of milk that we have to add to this mixture so that the ratio of milk and water becomes 4:1. So if we assume that the quantity of milk added is X liters, then the quantity of milk in the new mixture, it will be initially the quantity of milk in this mixture. It is 3/4 into 20. Then we are adding 1 X liters. So it is plus X. So this is 15 plus X. We are not adding any water. So quantity of water in the new mixture will be the same as quantity of water in the mixture initially. So here we have 20 liters of the mixture. It contains milk and water in the ratio 3:1. So in this the quantity of water is 1/4 into 20, which is 5. And now the quantity of milk in the new mixture upon quantity of water in the new mixture, it is in the ratio 4:1. So from this we have 15 plus X upon 5 equal to 4/1, or 15 plus X is equal to 20, X is equal to 5 liters. So if we add 5 liters of milk to this 20 liters of mixture, we will get milk and water in the ratio 4:1. So the correct option is option C, 5. Now moving on, a retailer buys 250 kg of rice, a part of which he sells at 10% profit and the remaining at 5% loss. If the net profit made by the retailer in the whole transaction is 7%, then the quantity of rice sold at 10% profit is. So here we can see that this question was given in last year's sample question paper term 1. The same question is there as an example in the CBSE Handbook. Here the retailer buys 250 kg of rice. So some part of this 250 kg is sold at 10% profit and the remaining at 5% loss, so that the net profit in the whole transaction is 7%. We need to find the quantity of rice sold at this 10% profit. So here if we take D as the direct quantity, which is the quantity of rice sold at profit. So here D is 10% and then C is minus 5%. The net profit made in the whole transaction is 7%. So the mean profit percentage is 7%. So here we have M minus C. So it is 7 minus of minus 5, which is plus 5, so 12%. And here we have D minus M. It is 10% minus 7%, which is 3%. So we have the ratio of dearer quantity, that is the ratio of quantity of rice sold at 10% to rice sold at 5% loss as 12% is to 3%. So dearer quantity is to cheaper quantity is 12/100 is to 3/100, or it is 4:1. So from this we can find quantity of rice sold at 10% profit. So quantity of rice sold at 10% profit will be 4/4 plus 1, that is 4/5 into 250. So this is equal to 200 kg. So quantity of rice sold at a profit of 10% is 200 kg. So the correct option is option A. Next question. In what ratio shall I add water to liquid detergent costing rupees 480 per liter to get resulting mixture worth rupees 300 per liter? Now this was given in sample question paper for this year, which is 2022-23. So we need to find the ratio in which we have to add water to liquid detergent costing rupees 480 per liter so that we get a mixture worth rupees 300 per liter. So here we can see that the cheaper quantity is water, which comes at 0 cost, and the dearer quantity is the detergent, which is costing rupees 480 per liter. We need to find the ratio in which we have to add these two so that we get a mixture worth rupees 300 per liter. So here C is the cheaper quantity, which is water, and the cost is 0. Dearer quantity, the cost is 480. The mean price M is 300 per liter. So it is 300. So here we have D minus M. So 480 minus 300 is 180. And here we have M minus C. So it is 300 minus 0, which is 300. So the ratio of water is to detergent. It is given by 180 is to 300, or it is equal to 3 is to 5. So the correct option is option C, 3 is to 5. And now we will see some other questions on alligation and mixture. In what ratio must a grocer mix two varieties of tea worth rupees 180 per kg and rupees 200 per kg respectively, so that selling the mixture at 216.2 he may gain 15%. So here we have to find the ratio in which a grocer mixes two varieties of tea worth 180 per kg and 200 kg respectively, so that this is the selling price of the mixture. On selling the mixture at this price, he may gain 15%. So first we have to find the cost price, that is the mean price of the mixture. So this is the cost of cheaper quantity. So it is C is rupees 180 per kg and D is rupees 200 per kg. We need to find M. Now we know that selling price equal to cost price into 1 plus gain percentage. So from this, the selling price is 212.2, cost price is M, into 1 plus gain percentage is 15%, or it is 0.15. So from this we have M is equal to 216.2 upon 1.15. Now this, when we divide, we get it as 188. So the mean price of the mixture is rupees 188 per kg. So if we draw the cross, C is 180, D is 200 and M is 188. So we have D minus M. It is 200 minus 188, which is 12. Then we have M minus C. It is 188 minus 180, which is 8. So the required ratio is, so the cheaper quantity upon dearer quantity is 12 by 8, or it is 3 by 2. Therefore, the required ratio is 3 is to 2. So the grocer has to mix the two varieties in this ratio. Moving on. Next question, how many kg of sugar costing rupees 45 per kg must be mixed with 30 kg sugar costing rupees 35 per kg, so that there may be a gain of 12% by selling the mixture at rupees 47.04 kg. So we have to find the quantity of sugar costing rupees 45 per kg that has to be mixed with this 30 kg sugar costing rupees 35 per kg, so that on selling the mixture at 47.04 per kg, there is a gain of 12%. So here let us take let Let x kg of sugar be mixed. X kg of sugar costing rupees 45 per kg be taken. So here the cost of the dearer quantity is rupees 45, cheaper quantity is rupees 35, and we have to find M. So again using the same formula, selling price equal to cost price into 1 plus gain percentage. Here this is the selling price. It is 47.04. It is cost price into 1 plus gain percentage is 12%, 0.12. So from this we get M as 47.04 upon 1.12. Now this, when we divide, we get it as 42. So the cost price of the mixture M is 42. So if we draw the cross, C we have 35, D we have 45, and M we have 42. So here we have D minus M. It is 45 minus 42, which is 3. And here we have M minus C, 42 minus 35, which is 7. So here cheaper quantity upon dearer quantity, it is given by 3 by 7. Now we have taken let x kg of sugar costing rupees 45 per kg be mixed. So we need to find this value of x. We already have this 30 kg of sugar. So this implies 30 by x equal to 3 by 7. Or we have x is equal to 30 into 7 divided by 3. So it is 70. Therefore the answer is 70 kg of sugar should be mixed. 70 kg of sugar costing rupees 45 per kg has to be mixed. So this is the answer. Moving on, next question. 3 varieties A, B and C of rice are mixed together in the ratio 4:1:1 respectively. The cost price of rice B is rupees 82 per kg and that of rice C is rupees 90 per kg. If the price of the mixture is rupees 94 per kg, then the price per kg of rice A is. Then find the price per kg of rice A. So here we can see that there are 3 varieties and it is mixed in the ratio 4:1:1. Now since B and C are mixed in the ratio 1:1, let us find the average price of B and C from the details given here and take this entire ratio as 4:2. So B and C together, the proportion is 2 and A the proportion is 4. So we have A is 2, B and C will be 4:2. We can find the average price of B and C from here since they are in equal proportion. And we also know the price of mixture. From this we can find price of A. So we have average price of B and C. It is given by 82 plus 90 divided by 2. So it is 172 by 2, which is 86. Then the mean price of the mixture, it is given as rupees 94. Let us take let price of A be X. So here we have A and here we have B and C. So price of A is X, price of B and C together is 86. The mean price M is 94. So here we can find the proportion of A as 94 minus 86. So here it is 94 minus 86, which is 8. And here we have X minus 94. So the ratio of A to B and C together, it will be 8:X minus 94. So quantity of A upon quantity of B and C will be, using this cross, it is 8 upon X minus 94. Now this ratio they have given it as 4:2. So we have 4 by 2 equal to 8 by x minus 94. This goes 2 times, this goes 4 times. From this we get x minus 94 equal to 4 or x equal to 98. Therefore, price of A is rupees 98. Rupees 98 per kg. This is price of A. Next question. A vessel contains a mixture of two liquids X and Y in the ratio 3:5. 8 liters of the mixture are drawn off from the vessel and 8 liters of X is filled in the vessel. If the ratio of liquids X and Y now becomes 7:10, how many liters of X and Y were contained by the vessel initially? So here we have a mixture containing two liquids in the ratio 3:5. From this mixture, 8 liters of this mixture was drawn off and 8 liters of liquid is filled in this vessel. After doing this, the ratio of X and Y becomes 7:10. So we need to find how many liters of X and Y were contained by the vessel initially. So let us take, let initially X and Y be 3x liters and 5x liters. 3x and 5x liters respectively. Now, after drawing 8 liters of mixture, quantity of X left will be, after drawing 8 liters from this mixture, quantity of X left will be 3x minus, here proportion of X is 3 by 8 and from that 8 liters is drawn. So, into 8, it is 3x minus 3. Then quantity of Y left will be, initially it is 5x minus proportion of Y is 5 by 8. So quantity drawn will be 5 by 8 into 8. It is 5x minus 5. And now 8 liters of liquid X is filled. So after 8 liters of X is added, quantity of X will be 3x minus 3 plus 8. So it is 3x plus 5. Now the ratio of X to Y is 7 by 10. Now we have 7 by 10 equal to 3x plus 5 upon 5x minus 5, or 7 by 10 equal to, this let us write it as 5 into x minus 1. So that this will go 2 times. So from this we get 7x minus 7 equal to 6x plus 10, or x is equal to 7x minus 6x is x equal to 10 plus 7, which is 17. So we have taken initially, let x and y be 3x and 5x liters. Therefore, initially there was 3 into 17 equal to 51 liters of x and 5 into 17 equal to 85 liters of y. So this is the amount of x and y that was present initially in this mixture. And now moving on to the next question. So, some of these questions I have taken from M.L. Agarwal book and the others from R.D. Sharma book. Two vessels P and Q contain milk and water in the ratio 5:3 and 13:3 respectively. In what ratio mixtures from these two vessels should be mixed to get a new mixture containing milk and water in the ratio 3:1 respectively? So here we can see that we have two vessels P and Q, and in these two vessels the ratio of milk and water is given as 5:3 and 13:3. Now we have to find the ratio in which we have to mix these two mixtures so that we will get a new mixture containing milk and water in the ratio 3:1. So part of milk in vessel P, it is 5/8. So it is 5/8. Similarly, vessel Q has milk and water in the ratio 13:3. So part of milk in vessel Q, it is 13 plus 3, which is 16. So it is 13/16. Then the proportion of milk in the new mixture, it is 3/3 plus 1. So it is 3/4. Now we have to find the ratio in which we have to mix P and Q. So here milk in mixture P, it is given by 5/8. Milk in mixture Q, it is given by 13/16. And we have part of milk in new mixture, it is 3/4. Now let us make all the denominators equal so that we will be able to find which one to subtract and accordingly find the ratio. So here LCM of 4, 8 and 16, it is 16. So 5/8, it is nothing but into 2/2. So it is 10/16. Here already the denominator is 16, so we can leave it as it is. Here 3/4 is nothing but into 4/4, so it is 12/16. So here we have 13 minus 12/16, which is 1/16. And here we have 12 minus 10/16, which is 2/16. So here the proportion of mixture P, it consists of this side. So it is 1/16, and the proportion of mixture Q, it consists of the value we get on this side. So it is 2/16. So quantity of P by quantity of Q, it is given by 1/16 divided by 2/16, or it is equal to 1/2. So here the ratio in which these two mixtures, that is the mixture of milk and water in vessels P and Q, it should be mixed in the ratio 1:2. So from this we get P:2 as 1:2, so that we will get a new mixture containing milk and water in the ratio 3:1. Now moving on, two vessels A and B contain milk and water in the ratio 3:2 and 7:13 respectively. They are mixed in the ratio 2:3. Find the ratio of milk and water in the final mixture. So here it is somewhat similar to the previous question, but we cannot go about in the same way as we have done the previous question. Here we have two vessels, again A and B, which contain milk and water in certain ratios. Now they have given the ratio in which they have mixed A and B. They have mixed A and B in the ratio 2:3. We have to find the ratio of milk and water in the final mixture. So here part of milk in vessel A, it is 3/3 plus 2, which is 3/5. Similarly, part of milk in vessel B, it is 7/7 plus 13, which is 7/20. Here we can see that we have 3/5 here, 7/20 here. So let us make the LCM. Let us make the denominator same. The LCM of 5 and 20 is 20. So 3/5 into 4/4, if we do, we will get 12/20. And now let us take part of milk in new mixture as x/20. So here milk in mixture A, it is 12/20. Milk in mixture B, it is 7/20. And milk in new mixture, it is x/20. So here whichever value is higher, that we can take as the dearer one. So here we have 12 minus x/20, and here we have x minus 7/20. 20. Now the ratio of this is given as 2:3. So quantity of A by quantity of B. It will be x minus 7 by 20 upon 12 minus x by 20. Now this ratio, it is given as 2:3. So this implies 2 by 3 equal to x minus 7 by 12 minus x. So from this we can find x. So 24 minus 2x equal to 3x minus 21, or 45 equal to 5x. So x is 9. So here part of milk in new mixture is 9 by 20. So we have part of water in the new mixture will be 1 minus 9 by 20, which is 11 by 20. So milk is to water, the required ratio, it is given by 9 by 20 is to 11 by 20, or it is 9 is to 11. So this is the ratio of milk and water in the final mixture. Moving on, from a container containing 50 liters of milk, 8 liters of milk was taken out and replaced by water. This process was repeated 2 more times. How much milk is left in the container? So this is, here we have a relation in finding the quantity of original liquid left after n dilutions. So that formula we have to use here. So here initial quantity of milk, that is x, it is 50 liters. Then quantity of milk taken out, y, it is 8 liters. And number of times this process was done, or this dilution was done, it is, that is, it was done once and then it was repeated 2 more times. So n is 3. So quantity of milk left after dilution, it is given by the relation x into 1 minus y by x the whole raised to n. So here x is 50 into 1 minus y is 8 by 50 the whole cube. So it is 50 into LCM is 50, 50 minus 8 is 48. I'm sorry, 50 minus 8 is 42. So 42 by 50 the whole cube. Now this, when we simplify, we get it as 29.635 liters. So this much amount of milk is left in the container after these dilutions. Moving on, from a container full of orange juice, 6 liters of juice was drawn out and replaced by water. This process is repeated 1 more time. The ratio of the quantity of juice and water left in the container is 9:16. How many liters of orange juice did the container hold originally? So here we have a container full of orange juice. From that, 6 liters was drawn out and replaced by water. This process was repeated 1 more time. So the total number of dilutions is twice. And now ratio of quantity of juice and water left is 9:16. We have to find the quantity of orange juice the container hold originally. So let us take, let initial quantity of juice be x liters. And now quantity of juice taken out y is 6. So it is 6 liters. And the process was done twice. So here n is 2. Now quantity of juice left in the container, it is given by x into 1 minus y by x. So it is 6 by x the whole square. Here we have the ratio of quantity of juice and water left in the container as 9:16. So let us take quantity of juice left upon initial quantity of juice. It is nothing but 9 by 9 plus 16. So it is 9 by 25. Now this ratio, it is nothing but the quantity of juice left is x into 1 minus 6 by x the whole square. Upon initial quantity of juice, it is x. This is equal to 9 by 25. So from this we get 1 minus 6 by x the whole square 9 by 25 we can write it as 3 by 5 the whole square. From this we get 1 minus 6 by x as 3 by 5. So 1 minus 3 by 5 equal to 6 by x, or 2 by 5 equal to 6 by x. 2 and 6 will go 3 times. From this we get x is equal to 15 liters. So the container held originally a quantity of 15 liters of orange juice. So the answer is 15 liters. Next question. How much water must be added to 60 liters of milk at 1.5 liters for rupees 20 so as to have mixture worth rupees 10 2 by 3 a liter? So here it is given 1.5 liters of milk is rupees 20. Now let us take, let x liters of water be added. So Cp of 1 liter milk, that is, it is the price of dearer quantity D, it is equal to 20 divided by 1.5, or 20 divided by 1.5, it is 20 by 1.5 is 3 by 2, so it is 40 by 3. And the cheaper quantity C, it is 0 because water comes at 0 cost. The price of the mixture is 10 2 by 3 a liter. So M is 10 2 by 3, or it is 32 by 3. So here we have C equal to 0, D equal to 40 by 3, and M equal to 32 by 3. So here we have D minus M, which is 40 minus 32, which is 8 by 3. Here we have M minus C, which is 32 by 3. So this side we have water and this side we have milk. So the ratio of water to milk is 8 by 3 is to 32 by 3. So this is 8 by 3 upon 32 by 3, or it is 8 by 3 into 3 by 32. It is 1 by 4. So the ratio of water to milk is 1 by 4. Now we have taken, let x liters of water be added to 60 liters of milk. So here quantity of water is x and milk is 60. This is equal to 1 by 4. From this we get x as 60 by 4, or it is 15. Therefore 15 liters of water has to be added. So the answer is 15 liters. So these are the different types of problems in alligation and mixture. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.